Alright, so the goal of this video is to look at how to factor higher degree polynomials. Like, for example, the one that you see here, the highest exponent in this problem is a 4. And most of the methods that we've learned so far deal with factoring things that are quadratics, which means the highest exponent is 2. So we want to look at how can we use what we know about factoring already, along with a couple of new and different looking tools to factor bigger polynomials, right? So if I'm looking at this particular example, the nice thing is that the first few are really just going to be using what you know for higher degree polynomials, and you're going to see it very quickly become something that you know how to handle. So if I'm looking at this, I'm going to say that this has a GCF of 3, right? Each of these numbers has a 3 in them, and there are also two x's, right? I can pull two x's out of this smallest variable. So I'm going to pull out a 3x squared as a GCF, and when I look at what's remaining, it looks like I have an x squared minus 2x minus 15. Okay, so I've actually removed the GCF, and now this remaining trinomial is something that we know how to factor using quadratic methods. So we can say that this is a quadratic trinomial. I can find things that multiply to negative 15 and add up to negative 2, and in this case those numbers are a negative 5, okay, and a positive 3. And then not forget that I pulled out a GCF, and that will also be a part of the factor. Right? So some of your higher degree polynomials are going to be simply GCF plus using your quadratic factoring methods, and you'll be able to break this down. So our goal when we're factoring is to try to break it down as much as we can. Right? A lot of times you'll see the directions, instead of saying factor, they will say factor completely. I know that I'm done because linear factors like x minus 5 and x plus 3 do not break down anymore, and 3x squared is a monomial, so we're not going to factor out a monomial anymore. So we're finished. That is the completely factored version of our 4th degree polynomial. So let's take a look at another one. Okay, so the same idea is happening here. It looks like I have a 5 for the numbers as a common factor, and I have only one x in common. Again, this smallest one only has one x, so I can't remove more than that. So let's see what's left over after we do that. It looks like I have 2x squared minus 5x, okay, and I pulled away a 5, so I have minus 3 at the end. Okay, so I'm going to have to factor this expression, which is also a quadratic trinomial. I just have to use the slightly more complicated AC factoring method on this one, and that's because this 2 is in the front. So again, for right now, we're going to leave the GCF out of it, and we're going to say what numbers multiply to negative 6 and add up to negative 5. All right, so if I say that my AC is negative 6 and my B value in the middle is negative 5, it looks like what multiplies to negative 6 that adds up to negative 5, well, that'd be a negative 6 and a positive 1. So I'm going to rewrite my expression, 2x squared minus 6x plus 1x, which I'm just writing for emphasis, minus 3. Okay, when I group the first two, it looks like there is a 2x in common, okay, and I'm left with an x minus 3. Okay, and in my second group, there's only a 1 in common, and I'm left with an x minus 3. And so the factors of 2x squared minus 5x minus 3 are 2x plus 1, which are my outside terms, okay, and the x minus 3 that you see repeating in there. And again, don't forget this 5x. This has got to come down. Technically, it was kind of sitting out there the whole time, but just to make it look a little bit nicer, we didn't write it in there. So we're going to say that the factored version of 10x cubed minus 25x squared minus 15x is 5x, 2x plus 1, and x minus 3. So you can see, again, this is a cubic polynomial. We don't have a specific method yet to handle cubic trinomials, but there are times where GCF will allow you to reduce the other factor into something that's quadratic, and then we can use everything that we know about quadratics. Okay, so that's the simplest method, using a GCF to factor. So let's take a look at some that maybe can't use that. So if I take a look at this now has 4 terms in it. Right, I have an x cubed, an x squared, an x, and a number, and this is something, again, that you've seen in Algebra 1. This is the grouping method. So anytime there are 4 terms, and in this case I don't see a GCF, nothing to remove, I'm just going to group the first 2 and group the second 2, and I'm going to do just like we did in AC factoring and remove something that's in common. So in this case, it looks like I see an x squared in common in the first group, and I'm left with an x minus 4. And it looks like I see a 3 in common, and I'm left with an x minus 4. Right? So if you notice, that's very much like the last step of AC factoring, and that's because it is the exact same thing as the last step of AC factoring. Okay? And so this is, again, a cubic polynomial, that I'm able to use the grouping method on when there are 4 terms involved instead of 3. Right, so here's a slightly more advanced version of that, and that's slightly more advanced because this has a GCF at the beginning, so it looks like I can remove a 3 from each of these terms, okay? And it looks like, again, just 1x, this last term only has 1x, so I'm going to remove that. And so here's what's remaining after I remove the 3x. It looks like I have x cubed minus 5x squared minus 4x plus, and when I remove the 3 from the 60, it looks like I have a 15 left. Oh, I'm sorry, a 20 left. All right, so let me remove that, put a 20 in there. So now I'm going to repeat the process, okay, and I have this remaining x cubed expression. Again, we're not done factoring until nothing can factor anymore. So this second factor, this x cubed expression, is also a grouping method problem. So I'm going to group the first two. Again, just kind of forget about this GCF for a minute. And it looks like I can remove an x squared. So let's remove an x squared, okay? And I'm left with x minus 5, okay? My second group here has a negative 4, and again, I'm removing the negative sign because I need a match here. So if I just remove the 4, I'd have negative x, and here I have positive x, so I need to remove the negative sign as well, okay? X minus 5, okay? And now let's regroup. It looks like x squared minus 4, and an x minus 5, and again, we're not going to forget that the entire time this 3x was sitting out front, okay? And so it looks like we're done, right? I factored just like I did in the last one, right? When I did this problem here, I factored, I got it down to an x squared and an x, and I was finished. And so we have to look at why this particular answer is not finished when the last one was. And the answer is that one of the factors that's left here can be factored again, and in this case it's the x squared minus 4. This can be factored into, if you remember, if I can write something as the difference, right, difference meaning subtract, of two squares, then I'm going to be able to write it as, right, x plus 2x minus 2. So I can actually break down x squared minus 4 one more time, and we have to keep factoring until we're done. So I'm going to say x squared minus 4 becomes x plus 2 and x minus 2, and then that x minus 5 also comes down. So this one actually has 4 different factors in my final answer.